Good evening, everyone. Today I am Kumar, teaching assistant of the course Fiber Optic Communication Technology, and this is taught by the Professor Diba Venkatesh, Associate Professor, IIT Madras. So this is the week 0 assignment solution. I have the solution. If you have any doubt in any question in assignment, then I will provide a solution. And if you have any doubt in the any lectures, so you can ask me in the chat box, or you can unmute on yourself and you can ask me the doubt. So assignment first question is the find the velocity of the wave of the frequency of the 20 hertz, and your wavelength is given 1 micrometer. So if 20 hertz in convert, we can convert it to 200 into 10 to the power plus 12 hertz, and 1 micro equal to 1 into 10 to the power minus 6 meter. So first you have solved, and if you have a doubt, then I will provide you the solution. So we have any sinusoidal wave in which we have a full wave like that. Time period will grow from t period, and it will for first half is positive side and second half is negative side, and frequency is inversely proportional to time period. So from 0 to maximum value of the wave is the amplitude, and from that 0 to t is the lambda, that complete cycle will be taken by the wavelength of the lambda, and how the velocity of propagation is how much is travel with the speed is that. So wavelength of the wave is the distance between the successive crest of the continuous wave. As a unit of the wavelength is, this is a continuous crest. Okay. These both are the continuous crest of that wavelength. So this is we have to be wavelength. Frequency of the wave is the measure of how many cycles. Means this is the first cycles, this is the second cycles, this is the third cycles, this is the first complete cycle. Wave complete every second. So it is the frequency. The estimated frequency will be hertz. Wave speed equation is the equation that calculates the speed of a wave given its wavelength and frequency. So velocity is equal to V equal to F into lambda. So V is the speed, F is the frequency, and lambda is the wavelength of the light. So in this question you have to calculate the velocity V. So you have to multiply the frequency into lambda. So velocity of the sound wave is V equal to that product of the frequency and amplitude of the wave. So you have to given the frequency of 200 terahertz and wavelength is 1 micrometer. So it is come around to 2 into 10 to the power 8 millisecond. So next question is the energy of the 1/14 of the visible light with the frequency equal to 500 terahertz is given. So you have to calculate the energy of the photon. Means your visible light will be expose any material or any semiconductor material. So how much the energy of the one photon is released due to that light wave you have to calculate, and you are given the your Planck constant equal to 6.6 into 10 to the power minus 34 into joule per second. So photon energy is the energy carried by the single photon. So energy carried by the single photon. The amount of energy is directly proportional to the photon's electromagnetic frequency, and thus equivalent is inversely proportional to the wavelength. So E directly proportional to the frequency, and it is inversely proportional to 1 by lambda. Okay. The higher the photon frequency, the higher is the energy. Because it is directly proportional. Equivalently, longer the photon wave, the lower its energy. So if the wavelength will be longer, then energy will be very less. So the whatever the low frequency light incident, it will generate a more photon and electron. Okay, so E equal to HF and E equal to SC upon lambda. So you know equations C equal to lambda F. So H is the Planck constant, F is the frequency, C is the speed of light, and lambda is the wavelength of the radiation. So you given that Planck constant is equal to like that, and frequency is 500 into 10 to the power 12. So it will approximately come around 3 into 10 to the minus joule, or between 3.5 to it will be range. Next question is which of the following Fourier transform pair are the correct. So you have to calculate the Fourier transform of the wave. Any signal is given, and you have to identify that which is the correct match. So the left side show the function, one is the function is the time domain, and right side represent the corresponding to the frequency domain. So one first option is goes the Gaussian pulse. So we have to calculate the Gaussian pulse. The Fourier transform of the Gaussian, ठीक है ना, the Fourier transform of the Gaussian is the Gaussian function we have to represent by the GT, and GT is defined equal to 1 upon 2 pi sigma into e to the power minus t upon 2 sigma square. So the Fourier transform of the Gaussian will preserve its shape. It will remain the Gaussian to the Gaussian only. So GF equal to inverse of the Fourier of the GT. So we have to, this is the time domain in frequency domain to time GT into e to the power minus j to 5 dt. This is the standard formula. So we have to put this value GT in place of the here. So you give the 1 upon under root 2 sigma pi, this will become outside, and minus infinity e to the power minus t sigma is equal e to the power minus j to 5 t. So when e to the power minus 2 sigma equal to, you have to take outside that, this will be give t square plus j to 4 pi sigma t square dt. So when you solve this mathematical equation, this is a square plus b square. So it is some format time and imaginary format, and when you solve it, it will again give the same format, e equal to minus 1 by 2 pi sigma pi square, like that. So Gaussian pulse will be remain Gaussian pulse. So it is the correct. So the above derivative make use of the following result from complex anisotropy and property of it integral equal to 1. So mu equal to this, so this will be equal to u. So the Fourier transform Gaussian pulse is equal to, so you have to got the same answer. Next is rectangle pulse equal to sinc square pulse. So Fourier transfer of the continuous time function xw can be, so transfer of the time domain is equal to in frequency domain into xw. So xw we have defined equal to minus that we have discussed also, xw equal to minus infinity xt equal to minus jt square. So this is that rectangle pulse. So we have take from time period minus t0 to t by 2. So its total time is equal to t, and its amplitude is equal to 1. So it is in the time domain we have to see, and this is the we have to convert. After that this will come in the frequency domain. So it will also come into the sinc function. So we have given that equation of that xt, we have to define xt equal to 1 for xt from this equal to 1, and for 0 otherwise it will be value equal to 0. So value of the xt equal to 1 when equal to time period equal to minus t by 2 t by 2. So it will be have written 0.5 t to 0.5 t. So we have to put this xt value in this above formula 1. So xw equal to minus infinity to infinity xt e to the power minus j omega t dt. So omega equal to 2 pi f, we have already know that. So either you have to put the omega or you can write the 2 pi f. So it is a time period we have to take from minus t by 2 to t by 2. So this is the time period you have to put here, and this is equal to e j omega minus t, because xt equal to 1. So when you have to put that xw equal to e to the power minus j omega t minus j omega 0.5 t to t by 2. So integral of the equation equal to minus j t by 1 j omega. So you have to take the integration, and you have to solve this equation. So it will be a minus b. So we have to take the cos a imaginary function. So cos a minus j sin b minus cos b plus j sin b, and so it will give you the solution to 2 sinc omega t by 2 omega, or either 2 pi f t by 2 by 2 pi f. So this will be 2 pi by t. One time period it will start from the 2 pi f by t, and this is another cycle minus pi by 2 pi by t, and this is 2t. The magnitude will become 2t. So this is the amplitude of that signal. So it amplitude will be also increase from that. Maybe it is scaling. So amplitude scaling we have to say. In case of the Fourier transform, there is a amplitude scaling, time scaling. These are the you have to in the ma'am also explain in the lecture slide also that. Next is the impulse train. Should be the impulse train. So the unit of impulse function is defined at. So this is the in the time domain form of the impulse function. So 0. So at 0 xt equal to 0 is 1 at x equal to 0, and it is 0 at x equal to minus infinite to infinite. So x delta t, we have to write the delta t equal to 1 for t equal to 0, and for 0 equal to t is less than equal to 0. If it is given that xt equal to delta t, so that equation we have written that minus infinity to infinity xt e की power minus j2 phi ft, this is equal to xf over. Okay, so we have to write this into these things. So x omega equal to minus xt equal to j minus x, so you have to put delta t will equal to 1. So as the impulse function exists only at t equal to 0, so xt equal to minus infinity, it is equal to 1. So e के minus 0 t equal to 1. Okay, so it is the in the frequency domain. So impulse function is also is the impulse train only. So these three options are correct. Next question, the electric field of the plane propagation wave is represented. So this is the equation of the plane propagation is in the three direction. We have x, y, and there is one z direction. Okay, so electromagnetic wave is traveling like in the three direction. And one is the z direction. Okay, so this is the equation of the plane wave electromagnetic plane wave. So a is your amplitude, it is the cos function, omega is the frequency or t is the time period, beta is the phase constant, z in the direction in which it will travel, and its unit is volt per meter. So in this question you have given that omega equal to pi, beta equal to 2 pi and lambda where n is. So you have given that there is a value of the n equal to 1. So only one waveform is there, only one cycle of the waveform is there, cos waveform, this only cycle. So EZT equal to 2 cos 12 into 10 power 90. So 2 is the amplitude, 12 is the frequency omega t, 20 is the phase beta. So you have to calculate the amplitude, wavelength, period of the wave propagation. So amplitude equal to 2 volt per meter, you can directly calculate. So wavelength lambda equal to, you calculate from this point of beta you given to 20. So you calculate directly from this, so it will come 0.3 volt meter. Period of the wave is equal to 2 pi by omega. Frequency equal to 1 by t. So you can directly, it is 0.5 nanosecond. Next question is choose the correct experiment when light travels from one medium to another. Like we have the two medium of light. This is the peripheral of that light. So like light is incident, like this is the incident light in, and this will either travel to this or either it will reflected. So this will make the angle theta, this is the theta r. So when light from, this is the reflecting index n1, this is n2. When light will travel from one medium to another medium, so what will happen? You have to ask that phase velocity will be changed, frequency will be changed, or wavelength will be changed. Okay, so this is the incident ray, this is normal angle of incident, this is reflected or angle of reflection. So we know that relation between frequency and energy. Previously I have given that E equal to HF. Okay, So where is the V is the energy of the photon. When light will travel from one medium to another, energy remains constant. Thus, from the above equation, we can say that frequency remains constant, because if energy is directly proportional to frequency. So in this case, frequency will be not change. We also know relation between velocity, frequency, and that C equal to lambda f. V is the wavelength, f is the frequency. So frequency will not change, then velocity will be also not change. So V is the velocity of light, lambda is the wavelength. When the light travels from one medium to another, the velocity of light changes. Only velocity. To compress this change, wavelength change too, or vice versa. Due to this change in frequency remain constant, as the wavelength and velocity of the light changes, whole traveling from one medium to another, then frequency does not change. Only wavelength and velocity of the light changes. Because incident frequency will remain, but it will, when we reflected, some light will be reflected and some light will take the reflection. That's why some only it's bending through the theta. That's why it will wavelength will be changes, or velocity, because one medium to medium its velocity will be also changes. Another question: a ray of light is traveling from a medium of the refractive index n1, like that previously question. This is normal angle, this is light, this is refractive index n1, this is n2. So light will be reflected, this angle r, this is refracted. Okay. What must be the angle of the incident theta for total interreflection? We know that sin theta I should be greater than critical angle. Critical angle means total right reflected reflection. It will become only like that. Okay. You see that theta I equal to greater than theta c. This no reflection will be there, only reflected will be there, and this is a dense medium water. So for total reflection, I sin theta equal to greater than equal to sin theta c. We know that sin theta c is 1 beta refractive index. So refractive index mu equal to n2 beta n1. Okay. So sin theta I equal to sin theta I is greater than equal to n1 beta n2. Okay. Or so theta c should be less than equal to sin I n1 beta n2. Okay. So this will be your correct answer. So another question is, according to Nyquist sampling theorem, the sampling frequency required to correctly represent a band limited signal must be greater than or equal to twice the highest frequency component. So you calculate the sampling frequency. So sampling frequency should be greater than or equal to 2 FM. Okay, FM is the maximum frequency of the signal. So your signal should be given that 4 sin 4 pi t plus 5 cos 10 pi t plus 0.1 plus cos 2 pi t. Okay, what is the maximum sampling frequency in hertz to represent the above signal? So sampling frequency, analog should be sample every TS cycles. Okay, so Fs inversely proportional equal to TS. TS is referred to sampling interval, or Fs is equal to sampling frequency. Okay, we have already given this. We can use the 3 sampling method: ideal and impulse at each sampling state, pulse of short we can sample, or sample and hold like natural bird. So this is the ideal sampling. We take the step of every step and sample the frequency. We take the whole waveform, or we take the step, flat and step. This is a flat type, flat top sampling. Okay. So according to Nyquist theorem, the sampling rate must be at least 2 times the highest frequency in the signal. Okay. So highest frequency is 4 pi ft. So this is the omega t, this is omega t, this is also omega t, and this is omega t. So in this, omega equal to 10 pi. Okay. So omega equal to 2 pi fm. Okay. So fm equal to 5. So sampling frequency should be 10 hertz maximum frequency. Okay. So next question is the match the following group 1, group 2. So we have to given that LED, laser, Bluetooth and optical fiber. LED should be light emitting diode. Laser is a light accumulation and stimulation reactor. Bluetooth we have used that devices, and optical fiber you know already. So you have to match which it should be. So in laser we have the spontaneous emission. Okay, because principle of the laser is spontaneous emission. So when electron will be generated, so it will be shifted from that primary electron from valence band to conduction band, or from L1 to K band. LED, in LED we have take the stimulated emission. Bluetooth is the 2.5 gigahertz bandwidth band, and optical fiber we have take the principle of optical fiber is a total internal reflection. So it will be like W. Lasers, LED laser should be W, LED should be and Bluetooth should be 2.0, and optical fiber should be total internal reflection. Telecommunication typically uses in telecommunication network we typically use it like the digital signal. Previously we used the analog signal also. So in telecommunication network is a group of nodes interconnected by telecommunication like that used to exchange message between the nodes. A link may use variety of technology based on a methodology of the circuit switching, pocket switching, pass the signal. Okay, so mainly we use the, now we have the digital signal like that pulse code modulation we use to transfer the signal 0, 1, 0 in the bit form. So we have to calculate analog signal into digital signal every time, and it will be converted in through ADC to DAC. So analog converter to digital converter, through which we can convert the signal and transfer the signal through the satellite, from satellite or tower to any from pocket to home to mobile and everywhere. Next question is, what is the wavelength range of the visible spectrum? So we have the full wavelength visible spectrum from 0 nanometer to around 2100 nanometer or above that. So around 400 nanometer we have the UV region, 400 to 800 nanometer UV visible, and 700 UV visible, and after that we have the IR region. So this is the visible spectrum of that wavelength from 400 to 700 nanometer. So 400 nanometer of violet color, around 475 to 450 to 475 is the blue region, then green and yellow and orange and red. So this is the solution of the week 0 assignment. So if you have any doubt regarding that solution, or if you have any doubt in the lectures, or if you are not understand, you can ask in the chat box. So one by one I can reply that. Okay, thank you.